Hey everyone, today we're going to check our applying parabolas practice. So first, remember we read our word problems with the purpose of finding the question. So a ball was kicked straight up into the air with a velocity of 80 feet per second. This function models that, and here's our question. How long does it take the ball to reach the maximum height? Well, if you'll remember, how long to get to a maximum height is your x of your vertex. So first, let's go over and graph this. So y equals negative 16x squared plus 80x. So I want to find my vertex. My vertex is at 2.5, 100, and the x of my vertex is 2.5. So to answer our question, it will take 2.5 seconds for this ball to reach its maximum height. Number 2, the function here models the height of a ball after it was thrown. How long does it take for the ball to hit the air? To hit the ground. So how long does it take for the ball to hit the ground? That is our positive x-intercept. So let's graph this function. So y equals negative 16t squared, or you can use t, but you can also use x, plus 16x plus 32. So I want to find my positive x-intercept, and that is at 2, 0. So how long does it take for it to hit the ground? 2 seconds. Oh, and by the way, let me write these in here so you'll see where I'm getting these answers. Okay, number 3, let's read to find the question. Read to find the question. Steve threw a ball in the air. The height of the ball after 2 seconds is modeled by this function. What is the ball's maximum height? So when you think about maximum height, that is the y value of the vertex. And remember, I'm getting this information from the graphic organizer we created in our last lesson. So the y of the vertex. So first, let's graph this function. Y equals negative 16t squared plus 40x, I use x instead of t, plus 144. Let's find our vertex. Do what you need to do there. Okay, so 1.25, 169 is our vertex. 1.25, 169. What is the y value of that vertex? xy, so it's 169. And it looks like they were talking about feet. It doesn't say it, but usually we measure height in feet. So this ball's maximum height was 169 feet. Number 4, the height of a ball kicked into the air can be modeled by this, where x is time in seconds. Oh, that's nice. It tells us that it's seconds. How long does it take for the ball to hit the ground? So that's going to be our positive x-intercept, or our positive 0. So let's graph the equation. So we have negative 16x squared plus 72x, and that's it. Let's see, plus 72x. Now, we want to know how long it took for it to hit the ground. So that's going to be our positive x-intercept, which is 4.50. That's the actual point from the graph. So how long? 4.5 seconds is how long it took for that to hit the ground. Number 5, a rock is thrown from the top of a 300-foot cliff with this velocity. After the rock is thrown, how long does it take the rock to hit the ground? So how long it takes to hit the ground is, again, your positive x-intercept. So we want to graph this equation. So y equals negative 16x squared plus 20x plus 300. And the question was, how long does it hit the ground? So my positive x-intercept is 5, 0. So it took 5, and rereading the problem, it was measuring time in seconds. Number 6, a ball is thrown into the air, gives you all the information. Here's the question. What is the maximum height of the ball? So when we talk about quadratic equations or functions and maximum height, that means we want the y value of the vertex. So let's graph our equation. Y equals, a lot of these have very similar equations. If you take physics in high school or calculus, you'll understand why. That's a specific relationship. So negative 16x squared plus 52x plus 5. And I'm looking for my maximum height, so I want my vertex, which is at 1.625, 1.625, comma, 47.25. 47.25. So the maximum height is our y value. So our ball reaches a maximum height of 47.25. And when I look back, I notice they measure our distance in feet. Number 7, I'm going to skim and look for the question, which, I mean, we could clearly go straight to it. Suppose the ball was thrown in the air for 2 seconds. What was the height of the ball? Okay, so this is one where we're going to have to plug it in. So it gives us the seconds. So that means seconds of 2. So I want to find h of 2 equals negative 16t squared plus 52. Oh, well, let's plug that in. T plus 5. H of 2 equals negative 16 times 2 squared plus 52 times 2 plus 5. So we can plug that straight in our calculator. We can also work that out by hand, but right now I want you to use your calculator. So negative 16 times 2 squared plus 52 times 2 plus 5, and you get 45. So to answer the question, it says, what was the height of the ball? 45, and when you read, it measures it in feet. So after 2 seconds, the ball will be 45 feet in the ground. And now let's look at 8. A baseball player pitches a baseball whose height can be modeled by this. How high will the ball be after 1 second? Okay, so this is very similar. We want to find h of 1. So negative 16 times 1 squared plus 80 times the height after 1 second plus 4. And again, you can work this by hand or you can type it in to your calculator. So negative 16 times 1 squared plus 80 times 1 plus 4 tells us that after 1 second, this will reach a height of 68 feet.